Good morning to all. This is Anvesh from Triple E branch. Uh, uh, my topic is about the wind energy system. Subject of wind and solar power system. So, coming to the introduction, the cumulative installation of the wind turbine has grown a fast pace over the last 2 decades. Installed wind power generation, which is currently large than 440 gigawatt, is expected to exceed 760 gigawatt by 2020, making this form of renewable energy a significant component of the modern and future energy supply system. Along with the fast-growing capacity, the power electronics technologies used for the wind turbine system has also changed dramatically in the last 30 years. So, in the 1980s, the power electronics in wind turbine was simply a soft starter, which is used to initially digital object identifier. So, interconnected a squirrel gauge induction generator to the power grid when the wind turbines start to produce the power because of they did not need to carry power continuously. Simply, the semiconductor thyristor will apply. So, in the solution, the rotational speed, the generator is fixed. Thus, the wind speed fluctuations are directly reflected mechanical torque fluctuations and then current fluctuations of the generator. Therefore, this solution requires stiff power grid and it's mechanically constructed must be able to support the high mechanical stress caused by wind gust. Moreover, the wind turbine cannot operate at its maximum efficiency in a broad range of wind speeds and thereby has reduced energy yield. In the 1990s, the power electronics technology was mainly used for rotor resistance control of wound rotor induction generator, in which more advanced power electronics devices such as diode bridges and choppers were used to control the rotor resistance for the generators. In this solution, the rotational speed of the wind turbine can vary in limited range, especially at the nominal power operation of the wind turbine, typically 0 to 10% above the generator's synchronous speed. Thus, the mechanical stress in the system can be reversed. Since 2000, even more advanced voltage source converters with bidirectional power flow has been introduced. The power electronics started to handle the generator power from the wind turbine continuously. First, the by partial scale of power capacity double leaf fed induction generators, and then by the full scale of the power capacity for asynchronous or synchronous generator by the induction power. Electronics converters, it is possible to fully control theoret- uh, theoretical speed of the generator and acquire many benefits. First, the wind speed fluctuations can be smoothly converted into the mechanical torque and electrical power with certain inertia by utilizing the kinetic energy in the blades. Moreover, the wind turbine efficiency can be optimized over a broader range of wind speed. Meanwhile, some ancillary services can also be provided for the grid thanks to the extra power control flexibilities introduced by the power electronic converters. So, the development of wind power generators and the power electronics. So, wind power has truly become an important component of the modern energy supply. The cumulative wind power capacity from 2001 to 2020 in the installed, the capacity of the wind power achieved 487 gigawatts with 54 gigawatts added in the 2016 alone. Wind power accounted for 55% of renewable power capacities globally, not included hydropower, and accounted for 3.7% of global electricity production by the end of the 2015. Several European countries have achieved relatively high level of wind power penetration, including Denmark 42%, Portugal 23.2%, Ireland 23%, Spain 18%, Germany 13.3% and the UK 11%. Other major wind power has significant amount of wind energy share in their power production. The United States 4.5, 4.7%, China and 3.3%, and the Brazil is 3%. So of the individual size and the power rating of wind turbine has also increased dramatically. The emerging size of wind turbine between 1980 and 2020 illustrate when the development of power electronics with its rating, coverage, and functional role are also indicated. In 2015, the average rating of the wind turbine installed in Europe was 2.7 megawatt for onshore and 4.2 megawatt for offshore, and now cutting edge 8 megawatt wind turbine with a diameter of 164 meter are on the market. Today, the major wind turbine manufacturers have issued products in the power range of 4 to 6 megawatts, and it expected that more wind turbines have 4 megawatt will erected in the next decade. The this trend is mainly driven by the need to reduce the cost of energy per produced kilowatt hour. With respect to the wind power markets and manufacturers in 2015, the China was the largest market with a over 30 gigawatt newly added in 2015, together with the United States 8.6 mega gigawatt and the European 12.8 gigawatt, sharing approximately 82% of the global market. So, summarize the companies are from China, the United States, and the European market shares with the wind turbine of 1.5 to 3.5 megawatts in the mainstream, the high end in terms of power level. So this is the global cumulative wind power capacity of the gigawatts. So first it is 24% and then it is 31% and it is gradually increasing to the 792%. So this is the gigawatt readings of the global cumulative wind power capacity. And this is the development of power electronics for the wind turbine between 1980 to 2020. Inside the turbine circle indicates the power rating coverages by the power electronics diameter of the rotate. So the first one, if you see, it was a 50 kilowatt and the diameter is 15 centimeters, 15 meters. And it's gradually increasing its diameter so that at lastly the circle of the diameter is 190 meters, um, and that power is 10 megawatts. So it is gradually decreasing the power and it is gradually increasing the and from bottom to up, gradually increasing the diameter. So controlled by the power electronics and thus rotational speed of rotor blades can be varied in satisfactory range to maximize the energy yield and reduce the mechanical stress. The relative small capacity of the power converters make this concept attractive from a cost point of view. However, its main drawback are the use of slip rings with the compressed reliability and insufficient power controllability in the case of grid or generator disturbances. Because of the power rating requirement of the power electronics converter is relatively small, the two-level voltage source converts topology in is most adopted in the DIFG based wind turbine concept. So normally 2L VSC are configured in a back-to-back solution throughout a common direct current DC link. So a technical advantage of this back-to-back solution is fully power control under the four quadrant operation. This solution has been relatively small structure with small component count, which contributes to well proven reliability as well as the benefit of low cost. So, and the next topic is synchronous and synchronous generator with full scale power converters. Another important concept which is popularly for newly installed wind turbines, the SEIG DC excited synchronous generator and the permanent magnetic synchronous generator has been reported as possible solution by introducing a full-scale power electronics converter and transformer to interface the power grid and the stator winding of the generator. The generated power from the wind turbine can be fully regulated. Compared to the DFIG based concept, the main advantage can be eliminate of slip ring, simpler or even eliminate gearbox of the extended speed controllability as well as a better grid support capability. So because of the power electronic converters in this concept need to withstand all of the generated power at multiple megawatt. The 2L VSC topology may suffer the high loss of the power level. Moreover, the cabling in the case of low voltage level below 1 kV with high current is a design challenge. In order to cope with the growing power capacity, multi-cell converter configuration has been introduced. The most adopted multi-cell converter solutions which have a multiple 2L VSC connected in parallel both on the the generated side and on the grid side, and it is connected that the wire connects on the generator side and DC links coupled could be different. The multi-cell converter configuration has been the advantage of the standard and proven low voltage converter technologies, as well as the redundant and modular characteristics. Therefore, it is state of the art wind turbine produced about 3 megawatts. The currently most new installations of multi-megawatt turbine are part of wind farms, which aggregate the individual contribution in a power station. Traditionally, the most of the wind farms are onshore based, but present plans and ongoing development exist for the large offshore deployments that would benefit from better wind conditions and are located away from land. The capacity of offshore wind farms can be up to 630 megawatt. For example, a Holt wind farm on Denmark is illustrated, and it is rated at 400 megawatt, and it compromises 1103.6 megawatt Siemens with turbine. Other top-rated offshore wind farmer includes. So this article has been accepted for inclusion in the future issue of the journal. Content finally are presented with the expectation of plagiation. On other hand, the high power capacity required the wind farm to be more active and able to provide the support to the power grid. The power electronics is again an enabling technologies or the wind farms in order to fulfill the growing demands. Some existing and future configurations of the wind farms employing power electronics are shown in the figure, which composed of 80 wind turbines rated of 2 megawatts because of the limitation of reactive power capability. So, coming to conclusion, so the individual power rating and installation and of wind turbine has been significantly increased over recent decades, such that wind energy now plays an important and growing role in the power system. A main driving factor is represented by the continuous need for sustainable and renewable energy at competitive prices. This review of state of the art solutions indicated that the power electronics technologies, including association controls, have significantly improved the operations and performance of WTS through the proper selection and configuration control and grid regulation, and it is now possible for the WTS and wind farms to act like a conventional power plant actively frequency and voltage control in the power. So these capabilities creates opportunities for the continued large-scale deployment of wind turbine and wind farms. Furthermore, driven by the need to reduce the cost of energy and enhance the performance of energy conversion. There are still many new possibilities for the advancement of power electronics technologies, including the development and application of new topologies and power devices, increased in the reliability and incorporation of energy storage and more power system control capabilities. So this is junction temperature of power devices, the 2 megawatt wind power converters with the different generators. So induction generators. So this is DFIG and it is PMSG. So there is a diode and IGBT, and here also there is an diode and IGBT. So this is a 1 year thermal profile under the given wind speed profile figure. So these are the temperatures that is giving some disturbances going of high and low. Thank you.